Let's look at your copper reacting with oxygen, forming what? So CuO is nothing but your copper 2 oxide, also known as cupric oxide. Done. Now let's look at balancing the equation. So we have CuO2 and CuO. CuO are the two elements that is part of the entire reaction. So first is we need to write all the reactants in the product at the top. I wrote that. And then the atoms that is involved in the reaction has to be written on the left column. Leftmost row. No, wait, this is column. Yeah, leftmost column. Then we'll count. This is 1, this is none. That is in Cu, there is 1 atom of Cu and no oxygen atom. In O2, no Cu, that is no copper atom, while you have 2 oxygen atom. Right? And CO, there is 1 and 1 of each. So is this balanced? Clearly no. So we'll multiply this with 2. So this has to be multiplied with 2. Reason being, if I want 2 oxygen under CuO, there has to be a pair of CuO. Your cupric oxide has to be 2. There has to be 2 of it to be present, for it to be present, for us to have oxygen as 2. Okay, think about it. Only with 2 CuO, we'll get 2 oxygen. Take a second. Yes, if this is 2 CuO, even the copper will be 2 of it. There will be 2 atoms of it. Think about it physically. Think about 2 atoms. There are 2 of this. So there will be 2 copper. Overall, there will be 2 copper. So LHS and RHS of copper is not balanced. So I'll multiply this with 2. And so this is with 2. So basically, we're looking at 2Cu, which is solid, plus O2, obviously. We have it in gas. And we need heat to kickstart this. Then you have 2CO, which is a solid. Now, the question is, how do we get to know if the reaction has happened? So obviously, one of it is changing color. Okay, so what happens? Well, a shiny reddish. So by now you guys should know that this is reddish brown. You know, many places we have encountered this. So copper metal, obviously what will happen? A shiny thing. This will react to form a black solid. So of course there is change, and that change is black solid. I guess. So black solid, copper to oxide. So the copper will be tarnished dark over time. With heating in the presence of oxygen, this happens. Heat and oxygen present, this happens. Then next is, let me show you guys the periodic table. Copper and oxygen. Copper has a valency of +2 and also +1. Oxygen has a valency of -2, and so we have CuO. And the potential difference, not potential difference, electronegative difference, and first ionization energy, electron affinity. So it's quite nearby. Things are quite nearby. Okay. So looking at this set of values, we can guess that it is ionic bond, but some bit of covalent characteristics as well. So that's how it is. Sorry, this is Cu, not Ca. Yeah. So we have Cu. This is your covalent, or actually metallic in this case. Metallic bond. And we have O2, that is your non-polar. Covalent bond. Why is it non-polar? All of that is explained. Basically, it is to do with this value, right? Both have the same pull, electron affinity. Since both have the same pull, it will go and stay near the center. Then you have CuO, which is ionic, plus a bit of covalent characteristics as well. So it's as simple as that. Then what else? Then we are looking at reduction and oxidation. So in this case, you have oxygen being added to Cu. So let's look at it. Oxidized. So who is getting oxidized? Copper. This is before and after. Before and after. So let me start fresh. So copper, and it became CuO. So when it was Cu, is its oxidation state, not oxidation state. Oxidation state is 0. And here the oxidation state is +2. Why? Because this guy wants -2. 2 minus 2. 2 minus actually. No, -2, correct. And this guy has to be Cu2 plus or +2. And so it moved from being 0 to 2. That is, it lost what? 2 electrons. And this implies oxidation. It got oxidized. As simple as that. Agree?